Do lesson 4.6 part 1 pre-calculus math today, classwork version of trig graphs. And today we got part 1, graphs of other trig functions. You have 4 points here that goes in your notebook, and then 48 points here in your classwork sheet. Get a hold of me for class note-taking guides. Teachers, today's bell work is determine whether the function is one-to-one. If it is, find its inverse function of f of x here and f of x here. Give your students about 5-6 minutes. Okay, welcome back for the solutions to today's bell work. Up here for number 84 is not one-to-one because of this square here, the square of this difference. It will not be a one-to-one function. This one is a one-to-one, and the solution to find this is you're taking the cube root of x minus 5, and then you cube both sides. You get x cubed equals y minus 5, and then you take the inverse of that, and you get x cubed plus 5 will provide your one-to-one situation here. That would be the inverse function of f of x. Okay, into our lesson today. The graph of a tangent function. Recall that the tangent function is odd. That is, the tan of negative x equals the negative tan of x. Consequently, the graph of y equals tan x is symmetric with respect to the origin. You also know from the identity tan x equals sine x over cosine x that the tangent function is undefined when cosine x equals 0. Two such values are plus or minus pi over 2, which is approximately plus or minus 1.5708. So here is a table of a tangent function here. And you have undefined negative pi over 2, and then you have an undefined pi over 2. And then everything else here is yields these results here. Okay, students, take that down on your classwork sheet. Tan x approaches negative infinity as x approaches negative pi over 2 from the right. And then tan x approaches infinity as x approaches pi over 2 from the left. So, as indicated in the table, tan x increases without bound as x approaches pi over 2 from the left and decreases without bound as x approaches negative pi over 2 from the right. So the graph, let's see the graph of y equals tan x has vertical asymptotes at x equals pi over 2 and x equals negative pi over 2. So here is the graph of the mighty tan function. And this tells you why here. It rises from left to right, but it just goes to infinity here at negative pi over 2 where it's not defined. And then at pi over 2 it's not defined. And then again here at 3 pi over 2 it's not defined. But it rises from left. Moreover, because the period of the tan function is pi, vertical asymptotes also occur at x equals pi over 2 plus n pi, where n is an integer. The domain of the tangent function is a set of all real numbers other than x equals pi over 2 plus n pi, and the range is a set of all real numbers. So again, here's the graph of your tangent function, and this describes the domain, and this, it gives us the range here is all real because it just goes in both directions here for infinity. So the tangent function, domain all reals, range is negative infinity, positive infinity, and then the period here is pi, so you go from negative pi over 2 to pi over 2, and that is your range, or rather the period of the tangent function. And then the x-intercepts are here, and pi, 0, y-intercepts are 0, 0, meaning here. And then the vertical asymptotes are x equals pi over 2 plus n over pi, n pi. It is an odd function, and it's symmetric to the origin here in relation. So let's get into an example here. Library of parent functions, f of x equals 10x. Sketch the graph of y equals 10 x over 2 by hand. So here's a table of that, of this function here, y equals 10 x over 2 by hand. Here's your table. It's undefined at negative pi because you have a vertical asymptote here. And then negative pi over 2 is negative 1, and then etc., etc. By solving the equations, x over 2 equals negative pi over 2 and x over 2 equals pi over 2, you can see that the two consecutive asymptotes occur at negative pi and pi. Between these two asymptotes, you plot a few points. So you plot these points here, including the x-intercept as shown. 3 cycles of the graph are shown here. These are approximate sketch-ins here. That would be how you would sketch in. And then using a graphing utility, you can confirm the graph. So this is approximately how it should look on your graphing calculator. So let's try one now, okay? So sketch a graph of the function, include 2 full periods. Use a graphing calculator to verify your result. So we have, for number 9, y equals 1/2 tan x, and then 10 is y equals 1/4 tan x. So for this number 9, the period is pi, like all tan functions are. Here's your table for this function here. And then 2 consecutive asymptotes will be negative pi over 2, then pi over 2. So that would be how your function will look for here, y equals 1/2 tan x. Okay, moving on to another example here. F of x equals 10x. So sketch the graph of y equals negative 3 tan 2x by hand. So by solving the equation, here are, first thing off, we have our vertical asymptotes here. By solving the equations, 2x equals negative pi over 2 and 2x equals pi over 2, you can see that the two consecutive asymptotes occur at x equals negative pi over 4, which is here, and then x equals pi over 4, which is here. Between these two asymptotes, plot a few points, including the x-intercept. Here is your table for this function here. And then here's your plots here to sketch in your function here, including the x-intercept shown in the table. 3 complete cycles of the graph are shown. So you can use a graphing calculator, and it should look something like that. You would have something like this, where now you're falling from left to right because of this negative 3 here, negative 3 tan. That also gives you kind of like the slope here for that. And using the dot mode of your graphing calculator, you should come up with something that looks like this here. This is what you should come up on your graphing calculator for that one. And this will be dot mode here. This is a more of a facsimile of what your screenshot on your graphing calculator should look like. So let's try one now of a tan function, y equals negative tan 2x, then y equals negative 3 tan 4x. So we have a period here of pi over 2. And then 2 consecutive asymptotes would be 2x equals negative pi over 2 and x equals negative pi over 4 is what that would become. So 2x equals pi over 2 would equal pi over 4. So we go from negative pi over 4 to positive pi over 4 as our vertical asymptotes here. And then this would be an approximation of what your sketch-in should look here on this grid here. And then down here, then let's just go ahead and use this as a model to produce a result here, produce a table, and then find out what your vertical asymptotes are by this method here. Oh, we are going to do so. Okay, so your period here is pi over 4. for this one. So 2 consecutive asymptotes would be 4x equals negative pi over 2, and then would yield x equals negative pi over 8. And then up here 4x equals pi over 2, which would yield x equals pi over 8. So, and then here's your table from this function here. And then this would be your facsimile here for the graph of this function here. The graph of y equals a tan quantity bx minus c increases between consecutive vertical asymptotes when a is greater than 0, here's your a, and decreases between 2 consecutive vertical asymptotes when a is less than 0. So when a is positive, it goes up from left to right. When a is negative, it goes down from left to right. In other words, the graph of a for a less than 0 is a reflection in the x-axis of the graph for a greater than 0. So this would be a would be greater than 0, and then this would be a less than 0. So you see the difference here for this part of this kind of tan function. Graph of the cotan function. The graph of the parent cotan function is similar to the graph of the parent tan function. It also has a period of pi. However, from the identity f of x equals cotan x equals cosine x over sine x, you can see that the cotan function is vertical asymptote when sine x is not equal to 0. So which occurs x equals n pi, where n is an integer. The basic characteristics of the parent cotan function are summarized here below. So domain all reals, range negative infinity, positive infinity, period is pi, x-intercepts are here, pi over 2 plus n pi, and then vertical asymptotes are x equals n pi. Odd is an odd function, and the origin, the symmetry is in relation to the origin here. Let's try one now. So for cotan x, sketch the graph of y equals 2 cotan x over 3 by hand. So to locate 2 consecutive vertical asymptotes of the graph, solve the equations x over 3 equals 0 and x over 3 equals pi. And to see that the 2 consecutive asymptotes occur at x equals 0, you have the asymptote here, then x equals 3 pi. So 3 pi here, and x equals 3 pi. So there would be your plot for that, for this part of the tan function here. It's falling from left to right. Then this one here, same thing here. You're falling from left to right. So the 2 asymptotes, then between these 2 asymptotes plot a few points, including the x-intercepts as shown in the table here. And 3 cycles of the graph are shown here of this function. Your y equals 2 cotan x over 3 by hand. Now if this was tan, a would have to be negative. In this case, a is positive and it falls from left to right. Isn't that interesting? So that note that the period is 3 pi, the distance between the consecutive asymptotes. So we have one here at 0, then this is 3 pi here, and then over here this is negative 3 pi here. So you have a period here of 3 pi, which is created by this x over 3 part of your tan function. Let's try one now. 1/2 cotan x over 2, and then down here we have 3 cotan x through pi x. So period here is pi over 1 over 2, which equals 2 pi. So that's derived from here. So your period is 2 pi. 2 consecutive asymptotes, x over 2 equals 0, x equals 0 would be an asymptote, and then x over 2 equals pi, and then that would be x equals 2 pi. So there are the asymptotes. Here's your table for this function here. And then this will be the graph here. Again, if you notice, that's the striking difference between the tan and cotan is it falls from left to right even though A is positive. And then down here, your period is pi over pi is 1 because of this part of your function. Two consecutive asymptotes will be x equals 0, x equals 1. We have a period here of 1. And then here's your table for this function. Here would be the graph of this function, and that is 4.6 part 1. Email me here for course materials, note-taking guides, and then notebook guides, and classwork sheets, homework sheets. Thank you very much.